Okay, so last time around we did a brief video on angles of rotation, but we hung everything up in the first quadrant. Now what we're going to do is we're going to look at what happens if I make an angle of rotation and it's any positive value. So all angles of rotation start with their initial side at the 0 radians or 0 degrees side, which is the positive x-axis, right? So when you're working in geometry, your angles can only get to 180 degrees. Beyond that, it doesn't make sense in the way geometry is set up. However, when I'm working in trig or with angles of rotation instead of geometric angles, I can have angles that are much larger. So let's say that this is a 300 degree angle. And if you make the conversions into radians, that is a 5 pi over 3 radian angle. Okay, so it is possible to have positive angle measures that are counterclockwise rotations that get more than 180 degrees, and actually they can just keep going into infinity because you can go around the circle more than once. Okay, so the question now is, like, how do we relate trig functions to this? These trig functions were, if you think about this, using a right triangle, right? So when we used a right triangle, that angle measure had to be less than 90. But now we're introducing angle measures that can go like from 0 to infinity. So what does this mean for like sine, cosine, and tangent of like 5 pi over 3? So the question is how do I handle this? Well, what you do is you take the terminal ray, the terminal side, and you examine the angle that is between that terminal side and the x-axis. So here, this would be a 60 degree or pi over 3 radian angle. Okay, so this is what we're going to refer to as a reference angle. Okay, so the way we handle this is that the absolute values of these are going to be equal to the values of those reference angles. So sine of pi over 3, which is root 3 over 2, cosine of pi over 3, which is 1/2, and the tangent of pi over 3, which is the square root of 3. Now, the only thing that's going to be different here is that this gives me the absolute values. Okay? The signs are a different matter. Now, we'll do a deep dive later about why this works, but if that terminating side ends up in quadrant 1, all three, sine, cosine, and tangent, will be positive. Okay? If I'm in quadrant 2, only the sine value will be positive. The cosine and the tangent will be negative. If I'm in quadrant 3, only the tangent value will be positive. So the cosine and the sine will be negative. And if I'm in quadrant 4, only the cosine will be positive. which means that the sine and the tangent will be negative. And some people like to remember this by all students take cookies. Okay, so all are positive in the first quadrant, just the sine in the second, just the tangent in the third, and just the cosine in the fourth. So, what does this mean? This means that if I take off the absolute values here, right? So let's kind of clear this out a little bit. If I take off the absolute values, the sine of 5 pi over 3 is the same as the sine of pi over 3, which is root 3 over 2, but it's going to be negative because I'm in the fourth quadrant here, and only the cosine can be positive. So the cosine of 5 pi over 3 is equal to 1/2, and that one's positive because I'm in the fourth quadrant and the cosine is positive. The tangent of 5 pi over 3 is going to be the square root of 3, but this one is negative because, again, only the cosine is positive. So we can play this game for any positive measured angle from 0 to infinity, so long as I can find the reference angle and then use the appropriate signage for the ASTC, all students take cookies, all sine, tangent, cosine, for the first, second, and third, fourth quadrants to get the correct sign for the correct function. All right, so we'll work with this a bit in class, but there's some examples and a basic set of notes on this topic.